Hi, Great Child. This is Miss Cantillon, just going over some more graphing. Okay, so from last day, you should know the shapes of the sine, cos, and tan graph. So here is a sine graph. The way I remember it's a sine graph is it kind of looks like a S. Oh, marker doesn't want to work. It kind of looks like an S by the x-axis. Notice that its period length is 2 pi. In other words, that's how long it takes before it starts repeating itself. And the way we graph this, if we needed to graph it, is we would take 2 pi, and there's 4 key points. 1, 2, 3, 4. I guess there's 5 key points. There's 4 intervals. 1, 2, 3, 4. That's a better way to put it. So we take 2 pi, we divide it by 4, we get pi over 2, and that's how we decide these numbers. Pi over 2, pi, 3 pi over 2, and 2 pi. That's how we decide to do that. Okay? Looking at the graph of cosine. Cosine has this general shape. The way I remember is it looks like a C right here. And again, it takes pi over 2 until it starts repeating itself. Its period length is 2 pi. If you divide that by 4, you get pi over 2, and that's how we decide how to do those intervals. Okay? Tangent's a little different. Its period length, the length until it starts repeating itself, is from here to here. It's pi, and if we divide that by 4, that is how we decided that each of these points, because we did pi over 4, and we added another pi over 4, which is 2 pi over 4, which is just pi over 2, plus another pi over 4 is 3 pi over 4, plus another one is pi. That's how we decided that. So it's very important that the period length of sine and cos are 2 pi. The period length of tan is pi. Okay, I just wanted to review that. Now, A and B values. So we saw what happened when we changed the value of this number right here. And that's known as, wait a second, the B value, I think? I think that's the B value. Let me look here. Yeah, that's the B value. So we change that B value. So the way I did this again in class is I just used my unit circle. So let's take my first point. Let's take at 0. Okay, well at 0 we have sine, we said that y equals sine of 2 times 0. So we have y equals sine of 0. Well, the sine of 0 is just 0. So at this point, it's 0. Okay, next I'm going to try and do pi over 2. And I'm going to put it here because I know what I'm doing. So the sine of pi over 2. Actually, I'm going to pause and think for 1 second. Okay, I was doing that right. So we're doing pi over 2. So y equals sine 2 times pi over 2. That's the same as saying y equals sine 2 pi divided by 2 is just pi. So when we enter in the value of pi over 2, we spit out the value of sine pi. Well, the sine of pi is right here. We get the value of 1. Let's decide 1's right here. No, the sine of pi, that's what I'm doing wrong. Sine of pi, pi is all the way here. Sine of pi is 0. Good. I knew something was wrong. 0. Okay, well, what happens if we went halfway in between? If we did pi over 4. So we go sine of pi over 4, sine of 2 times pi over 4, and the reason I put a 2 there is because that was our equation. Sine of 2 pi over the 4 is the same as sine of pi over 2 Well, what is the sine of pi over 2? That's right here is 1. So we're going to put a value of 1. And in fact, if we went on and did this, we would see that the graph looks like this. This is exactly what we did kind of at the beginning of last class. So comparing this to a normal sine graph, it looks the same shape. The only difference is the period. So normally, remember pi's period, or sorry, sine's period was 2 pi. Now we see that sine's period is pi. We have basically divided it in half. It has a shorter period length. Okay? Now, to decide how often we put the points, we just divide by 4. Remember before we did it every pi over 2, but in this graph we do every pi over 4. So it seems like when we change the b value, we change the period length. So in fact, when we made the b level 2, our period length was cut in half. Okay? And there's actually a formula I want you to write down. Period length is equal to 2 pi over b for sine and cos. So add that to your notes. We didn't do that before. And period length is equal to pi over b for tan. Okay, so if I gave you an equation, sine of 3 theta, the period length of this would be 2 pi divided by our b value, that's our b value, would be 2 pi over 3. Now if I wanted to know where each of my points on my graph are, where I'm going to just follow that same sine shape, oops, sine shape, that's a funny thing to say, like that. If I wanted to know where, 1, 2, 3, one more point, if I wanted to know where to do that, I would take my period length and divide it by 4. I would go 2 pi over 3, all divided by 4. So I kiss and flip dividing by 4 is the same as timesing by 1/4. I would get 2 pi over 12. In other words, I would get pi over 6. Does that work? So I would have pi over 6. 2 pi over 6 is like pi over 3. 2 pi over 6 plus another pi over 6 would be 3 pi over 6. So this would be pi over 2. And then we would have 4 pi over 6, which is the same as 2 pi over 3. Yeah, that does it. Okay? We'll move on to our next one. Here we have y equals -3 cos of 2/3 x. Okay, so this number, this a value here, that affects what? A affects amplitude. So instead of having an amplitude of 1, this is probably going to have an amplitude of 3. But there's a negative. So instead of being a cos graph like this, I'm going to anticipate it's going to be a cos graph like that. Okay? And then we're going to look at this number here, 2/3. So that's going to affect my period. So remember, my period length is equal to 2 pi over b. B in this case is 2/3. Well, let's fix that up. 2 pi over 2/3. So that's going to be timesing by 3/2. So that's going to be, is that just going to be 3 pi? Does that work? Let's look at my math. 2 pi times 3 pi, 3, sorry, over 2. Yeah, that's just 3 pi. So this whole thing is 3 pi, but now I need to put it into my intervals. So I'm going to divide by 4 to get my intervals. So each one is 3/4 pi. So this is 3/4 pi. 3/4 plus another 3/4 is 6/4 pi. I'm just going to jot that down. 6/4 pi can be simplified to 3 pi over 2. Okay, plus I'm going to add another 3 pi over 4. So that's 9 pi over 4. I don't think I can simplify that. Well, what's 9 pi over 4 plus another 3 pi over 4? That gives me 12 pi over 4. And is that 3 pi? Yes. So that tells me my intervals. And now I can just plot the points. Okay? So normally a coast graph we said would go like this. Would go do 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 following that. However, because it is a negative coast graph, instead of starting at a positive, it's going to start at negative. And because its amplitude is -3, we're going to start but down here, and we're just going to follow the same pattern. Okay, now it would just be symmetrical here. So just follow in that same pattern. See if I can butcher it. Okay. The other thing you can do is you can enter this into your graphing calculator and it will graph this. The only thing is we have to work on how to set up the axes. But to give you the general shape of like what it's doing at right here, putting it in your graphing calculator with your y equals is a really good idea. So have you started to see the pattern? The values at each interval are simply the coordinates on the unit circle. You should soon have the shapes of sine, cos, and tan memorized. Okay, we're ready for a hard one. Tangent. Okay, remember that shape of tangent, let's look at, it's always like this, and its period length was pi. It looks like that. It doesn't have an amplitude, but it does. This value is normally 1. Oh, geez. This value is normally 1. So maybe that could be affected. So let's see what we've changed in this one. So we're graphing y equals 1/2 tan of 3x. Now amplitude isn't really defined, but it is going to, at a certain point, it is going to go to about 1/2. So amplitude, I'm going to put a question mark, is about 1/2. Okay, and then our b value is equal to 3. So that affects our period length. And remember for tan, period length equals pi over b. For sine and cos, it would be 2 pi over b. B in this case is 3. So we have our entire period length, this whole thing is going to be pi over 3. But remember there's 4 critical points. There's 4 intervals that are important. So we're going to have to figure out what those intervals are. So we're going to divide that by 4. So pi over 3 divided by 4 is the same as pi over 12. So now we're going to work on our twelfths. So this is pi over 12 plus another pi over 12 is 2 pi over 12, which is the same as pi over 6. And I have 3 pi over 12. I'm going to jot this down. 3 pi over 12 is the same as pi over 4. Okay, and then I have 4 pi over 12. 4 pi over 12 is the same as what? Pi over 3, which was our period length, so we did something right. Now let's mirror that. Negative pi over 12, pi over 6, oops, that should be negative pi over 4, negative pi over 3. So we're going to get really good at fractions, guys. You'll see, you'll start to get really good at adding by twelfths and by sixths and things like that. Okay, so it's going to follow the exact same pattern as a tan graph, only its amplitude is going to be negative 1/2. And I say amplitude. So tangent, remember, started at 0. It went up. It went down. I should be using a different color to be a good mathematician. There we go. Over here, at this point, it's going to have go up. And if we wanted to continue, it would go down like that. At this point, it would be its amplitude. And if we were good, it would keep going like that. So again, its period length is pi over 3. If you cut this pi over 3, if you cut that right there, that's the part, and then it starts repeating itself again. Okay, I want to talk a little bit about your assignment. Insert blank page. Where are you? There we go. Okay, your assignment, it says you need to make 3 graph overlays. So you're going to use the transparent paper, the overhead paper, and I'm holding it up. Can you see what I'm talking about? A marker. And what you're going to do is you're going to take your graphs of sine that you made and already handed in. So you're going to grab them. So you have a beautiful graph of just a regular sine. Then you're going to put a blank sheet of paper over top of clear paper. And now you're going to go sine y equals sine 3x or something. You're going to do one where you change. Okay, so you have to do one where you change an a value. So that's um, an a value, one where you change a b value, and one where you change an a and a b value. And one has to be on a sine graph, one has to be on a cos graph, and one has to be in a tan graph. But you might want to, switch up what goes together. But you need to change each of those values and put it on a graph overlay. Now you have Thursday and Monday. What am I looking at here? Oh, you have Thursday and Friday to work on this, I believe. I might be looking at the wrong schedule. Anyways, you guys have the schedule. You know what you need to work on. So work on this and ask me questions Monday when I get back. Have a great February break.